Alright students, today we're going to talk about how we can use formulas to calculate the surface area of our prisms and cylinders. By the end of this lesson, we want to be able to apply formulas to calculate the total and lateral surface area of the prisms and cylinders we're going to see in our examples. So as we've been discussing surface area, we've been focusing on deconstructing the three-dimensional figure into the flattened two-dimensional nets, and we've been calculating the areas of all the pieces, all the different faces of the shape, and then we've been adding those together to get our surface area and our lateral area. Today we're going to discuss how formulas can help shortcut this process and make it a lot simpler to get to that final answer without having to develop that net and deconstruct it. So first of all, let's review. Surface area is the sum of the area of all the sides of a 3D shape, whereas the lateral area is simply the area of all the sides without the bases. So it's very important that we're able to identify what shape the base is of our three-dimensional figure. Okay, so let's discuss prisms first. We've got two different types of prisms that we focus on as junior high students. We have rectangular prisms where all the sides are rectangles, and triangular prisms where the bases are triangles but the sides are rectangles. So prisms have two parallel bases that are congruent, meaning they are equal in size. So for our rectangular prism, we have the ability to kind of choose our bases. A lot of times the base is chosen for us and is shaded so that we know which one to use, that we use the right one. So if the base is already shaded for you, then use the shaded base. If it's not shaded, you can choose which two parallel rectangles to use. A lot of times it's the bottom and the top. However, sometimes it can be the two sides or the front and the back. For a triangular prism, it's really simple because the triangles are the bases. So we can identify those pretty easily and shade the triangles immediately. So the formulas are developed with the understanding that if I want to find the lateral surface area, if I want to do everything but the bases, for a rectangular prism, that would mean that I would need to find the perimeter, that's what the P stands for, perimeter of the base. The perimeter of the base would add together all of those outside edges, okay? And then I'm going to take that perimeter and I'm going to multiply it by the height, okay? The height of my prism. How far apart are the bases from each other? When I do that, I'm essentially multiplying 4 times 8, and I'm multiplying 12 times 8, and I'm multiplying 4 times 8, and I'm multiplying 12 times 8, and I'm doing all of it at one time so that I can get all those 4 rectangles that are wrapping this box. I'm multiplying all of those lengths times the height at one time by finding the perimeter first and then multiplying by 8. I'm doing it all at one time. With a triangular prism, same concept. Okay, I'm finding the perimeter of the base and then I'm multiplying by the height of my prism. The height is how far apart the bases are from each other. So the 8 would be the base, or would be the height in the triangular prism. The base would be all the perimeter of this triangle. So 3 plus 4 plus 5 would be the perimeter. By multiplying the perimeter times the height, I'm adding all those rectangles that are wrapping these triangles. I'm getting all of those at the same time. Okay? So perimeter times height will give me the lateral. Now, to get the total surface area, I then need to find the area of the base. That's what the big B stands for. The big B stands for area of the base. So by finding the area of the base and understanding that there's 2, so I need to multiply by 2, I'm taking care of the area here and the area here, and then that gives me the total when I add it back to that perimeter times height that I've done the first step. Okay? So by finding the area of the base and timesing it by 2, I'm now taking care of those two faces of the prism. Okay, let's practice a rectangular prism and a triangular prism using the formula. Before we do that though, we need to understand the steps. So the first thing I want you to do is shade the base. If the base is not shaded for you, shade the base, okay? Then we're going to we're going to calculate the perimeter of the base. So we're going to find the P, okay? Then we're going to find the height of the prism. Then we're going to calculate the area of the base. That's going to be our big V. And then we're going to plug it into the formula and solve. Okay? Take a minute and make sure you write down all these steps before moving on to the examples. For example number 1, we have a base that's already shaded for us, but we're going to go ahead and shade it again just so that we have it identified a little bit easier. So our base is, for this particular example, the bottom. Okay? So after we have identified the base, we're going to find the perimeter of that base. Okay? Perimeter of the base is just adding up all the sides. So we have 19 plus 14 plus 19 plus 14. Okay? So the perimeter would be 66 inches. Okay? Then I'm going to identify my height. The height is the distance between the bases. So if this bottom is the base, then that would make the top the other base that's parallel. So that would make my height the 11 that connects the two together. Okay? So I'm going to use 11 inches as my height. Big B stands for area of the base. So I'm going to multiply base times height of my rectangle. So 19 times 14 would give you an area of the base of 266 inches squared. Okay? So now that I have perimeter, height, and big B, I am now going to write down my formula. So surface area equals perimeter times height plus 2 times big B. The perimeter is 66. 66 times the height is 11. Okay? So 66 times 11 would make my lateral surface area 726. Okay, 726 inches squared would be the lateral surface area. That's all of the 4 unshaded rectangles, all those areas added together. Okay? 2 times big B, so big B we already calculated was 266. So 2 times 266 would be 532. So 532 inches squared added to the 726 inches squared would mean that my total surface area is 1,258 inches squared. This would be my total surface area. Alright, y'all. Let's look at a triangular prism now. Okay? So again, we're going to shade the base. Now with a triangular prism, the triangles are automatically my bases. So I'm going to shade the triangles. So here's a triangle here. And there's another parallel triangle in the background. I'm going to shade both of those. Okay? The perimeter of my base is since my base is a triangle, I'm going to add 4 plus 11 plus 9. Okay? So we get a perimeter of 24 meters. Then we are going to find the height. The height is how far apart my bases are from each other. So even though you see this triangle and you see, oh, it's 3 meters tall, that's the triangular base that's 3 meters tall. The height of the prism, though, is the measurement that connects the two bases together. That would be the 5 meters on the side right here. So height does not mean vertical up and down. Height means how far apart are my bases. In this case, my bases are 5 meters apart. Okay, now big B is the area of the base. For this particular base, we know the area formula is base times height divided by 2. Base and height on a triangle have to create a 90-degree angle. So we're looking for that 3 meters that is running down the middle to the 11 meters that is running on the bottom here. So 11 meters times 3 would be my base and my height. 11 times 3 is 33, and 33 divided by 2 would give me an area of my base of 16.5. we would label this meters squared because it is area of the base. Okay, we've got our P, we've got our H, we've got our big B. So now we're going to find the total and lateral surface area. Remember our surface area formula, PH plus 2B, okay? So P is 24, H is 5, so 24 times 5 would mean that my lateral surface area is 120 meters squared. Alright, now plus 2B. So my B, I'm sorry, I shouldn't have written B again. My B was already calculated at 16.5, so 2 times 16.5. Okay? 2 times 16.5 would be 33 meters squared. So my total surface area is 153 meters squared. Lateral surface area is at 120. Alright, so now let's take a minute and talk about cylinders. Okay? So cylinders are very similar to prisms. We have two parallel bases. This time, though, the bases are circles. Circles have their own special relationship, and we have that wonderful relationship that involves pi developed to where we understand that when we're calculating the circumference of a circle, we would need to multiply pi times diameter, and when we're calculating area of a circle, we would need to multiply pi times radius squared. Okay, so lateral surface area, if you remember from the cylinder video, lateral surface area is just the rectangle that wraps around the circles. The rectangle would still be base times height, okay, base times height, but the problem is with a cylinder, a lot of times the base is not given, this distance around the rectangle. But we do know that the distance around the rectangle, the distance across the rectangle is the same as the distance around the circle. So the circumference would be this base right here. 2 pi r would be my circumference. If I multiply 2 pi r times my height, I'm going to get this shaded rectangle. That would be my lateral surface area. My total surface area would be taking that lateral surface area and adding to it both of my circles. Now, to find the area of one circle, we would do pi times radius squared. Since we have two of them and they're the same size, we're going to take that pi r squared and multiply by 2. Okay? So really all we're going to need for a cylinder is we need to identify the r, which is the radius, and we need to identify the h, which is the height of the cylinder. How far apart are my circles from each other? If we know the h and we know the r, then this formula can be very quick. Okay? So let's go into an example. If I have a Campbell's soup can and I'm creating a new label, if a can has a height of 6 inches and a diameter of 4 inches, how much material does Campbell need for each soup can? Okay, so think about a soup can. There's my can. I'm going to draw one. It's always good to draw a picture. I'm going to label it with the height of 6 inches. That's how tall my can is. That's this distance from the two circles. Put a 6 inches here. My diameter is 4 inches. So across the top circle, I'm going to put 4 inches. Okay. Now I just need a label. And we talked about this in class. The label is the amount that's going to wrap around the circles. That's the lateral surface area only. So we're just doing lateral surface area. Lateral surface area is that 2 times pi times radius times height we just talked about. The circumference, okay, is this piece times the height. That will give us this rectangle. Because we know that this base is the same as the circumference, and height is how far apart the two circles are from each other. So radius in this case would be half of the 4, because 4 is diameter. So 2 times pi times 2, because we're doing half of that, okay? And then our height is the 6 inches. So we can multiply this in any order. I told you guys in class, get all the whole numbers multiplied together first. Okay, so 2 times 2 is 4. And if I take 4 and multiply by 6, I get 24. So 24 pi is the lateral surface area. Okay? 24 times 3.14 would be approximately 75.36 inches squared would be my label on my soup can. Okay guys, you have two examples. I want you to try your best to use those formulas in the video to find the lateral and total surface area of my triangular prism and find the lateral and total surface area of my cylinder. Okay? Remembering that the formula for the prism is surface area equals perimeter times height plus 2 times the area of the base. And for the cylinder, surface area is 2 pi r times height plus 2 pi r squared. Okay? In both of these formulas, this is the lateral area plus the bases. Lateral area plus the bases. Okay, so practice the formulas, plugging them in, calculating that perimeter, calculating that area of the base. We'll talk more about this tomorrow. And again, you can always fall back on deconstructing it down to the nets, finding the area of all the faces individually, and then adding those faces together.